In this video, we will review a research article. The main task will be to convert PDEs into ODEs. If you are working in fluid mechanics, then the first task is to build a model and then convert that model, which is in a form of partial differential equation, into ordinary differential equation. Since I already shared many BVP4C code for different articles, so I will not share the BVP4C code for the current article, but the main aim will be to convert PDEs into ODs. For that purpose, I selected a 2009 paper. It is Ishak, Roslanda, and Pop paper. At that time, such work was very important in the sense that they developed, or maybe they set a tone for the future work. In today's time, such work looked like a very simple one, but at that time, it was an important topic, important model. So let me just start with the continuity equation. As you can see that this is unsteady flow problem, and in the continuity equation there is no time derivative. The reason is when we have continuity equation plus del dot rho v is equal to 0 and rho is constant, it means that this will be equal to 0 and del dot v will be equal to 0, and we get partial v by partial y is equal to 0. That's why there is no time derivative in continuity equation. In momentum equation, we have time derivative, convection terms, then we have diffusion, and this is the gravity term, which is actually called Buoyancy effect. If you download this paper, the geometry will look like this. There is a sheet sitting vertically. So your problem or your boundary layers will appear in the y-axis since there is a gravity. Then we have a energy equation. There is convection term, diffusion term, and the unsteady flow. At that time, or maybe nowadays as well, in fluid mechanics, there were no U and V. So the similarity variables were eta, stream function, and theta. Then we had UW, which is actually a condition over here, UW and TW, wall temperature and velocity at the wall. From fluid mechanics, we know that there is a connection between stream function and velocity u. So first we need to find u and v. This u we have to put over here, and so on, wherever it is needed. So first we calculate u. We apply chain rule over here. And after solving it, we get u like this. Nowadays, it is a common practice to give you u like this, ax1 minus ct f dash eta directly. So they can give you the stream function, but they also calculate u and v. Then we calculate v, and since eta is a function of only y, so partial eta by partial x will be 0 somewhere over here in the calculation. You can pause the video and calculate these velocities yourself if you are new to this field. So v will be equal to this term. Now, how we know that this u, the u we calculated earlier, this one, and this v is correct. If you calculated it wrongly, then it will not satisfy the continuity equation. So we should put these u and v into the continuity equation. In continuity equation, we have partial u by partial x, partial v by partial y. We calculate these two values, these two over here, then put into the continuity equation, and you can see that this is equal to 0. Now the next task will be to transform the momentum equation. This is momentum equation uh, into ODE. So all the terms we will calculate over here. This is momentum equation. We calculate partial u by partial t, and the final answer will look like this. Then we calculate u partial u by partial x, which appear over here. You can take a derivative of u with respect to x, then partial u by partial x will be equal to this term. You can pause the video and calculate these yourself. This is dash. Then we have to calculate this term, then we calculate these terms, and finally, after calculating all these terms, we have to calculate Beyonce term. The Beyonce term is, for Beyonce term, we have this thing, and we already know that theta is t minus t infinity, tw minus t infinity. So tw minus t infinity will be equal to t minus t infinity. So we can put the value of tw over here. The tw was already defined. This is tw. We can actually calculate tw minus t infinity from here, bx1 minus ct whole square, right? So in Beyonce term, after calculation, we have this term, and actually in Beyonce term there is no tw. There is no tw, but there is t minus t infinity. So we calculate Beyonce term like this. Substituting all these values into the momentum equation and momentum equation first, and divide by this term, we will get this third order ODE. This is third order ODE. The next task will be, it is similar to the momentum equation. Here we calculate partial t by partial t first. Then remember that we need to put this value somewhere. And again, we calculate u partial t by partial x, v partial t by partial y, and then we calculate the right hand side. Nowadays, as you may see, there are many terms involved like viscous dissipation. Then we have, for example, we have source term, so on and so forth. And there are some other equation as well, concentration equation, microorganism, so on and so forth. So finally, we got the energy equation as well. Now we convert the boundary conditions. At the boundary, we have this value. At wall, we have, I already told you what is TW, and the boundary condition becomes like this. The only step is remaining in this paper is to find out the skin friction, how much resistance is there when the fluid flows over a sheet. This is CF. We are again calculate partial U by partial Y from here. This is partial U by partial Y. Then again we have this term, then skin friction coefficient, and we multiply again. We calculated two terms like this and this one, and solving it further, we get the multiply with Reynolds number, we get a term like this, a term like this, and after dividing two on the left hand side. For Nusselt number, this is also very important since it calculates how much heat is transferred into the fluid from the wall. QW is this term. We calculate partial T by partial Y, use this expression, this equation, put into the equation over here, then calculate Nusselt number, and finally we have minus theta dash 0. So you can just pause the video and calculate all these, convert all these PDEs into ODEs. Thank you for watching.